This is Barcodes in one lesson. Barcodes are found on virtually all products that you see in any store. When a laser from a computer scans a barcode, it's actually scanning through a series of 95 evenly spaced columns and checking to see if each one of those columns is reflecting a lot of laser light or virtually none. Computers only understand ones and zeros, so any of the columns that reflect virtually no light are considered a 1. And any of the columns that reflect a lot of light are considered a 0, probably the reverse of what you might expect. So in this example, the computer begins reading the columns from left to right. The first column reflects virtually no light, so it considers that a 1. The next column reflects a lot of light, so it considers that a 0. The third column is like the first. It reflects virtually no light, so it also considers that a 1. The fourth, fifth, and sixth columns all reflect a lot of light, so they are all considered zeros. The computer continues reading the columns all the way across the barcode and comes up with a number that is 95 digits long, full of ones and zeros. These ones and zeros are then grouped into 15 different sections. 12 of these sections are used for the numbers that you see at the bottom of the barcode. The other 3 are used as guards. These guards let the computer know where the barcode begins and ends, and also where the 6 numbers on each side begin and end. This is important because the numbers on the left are identified based upon one set of codes, and the numbers on the right are identified based upon another set of codes. These codes are different because the computer needs to know whether it's reading the barcode from left to right, or whether the barcode is being read upside down. It figures that out based upon how many ones there are in the code for each digit. The codes on the left always have an odd number of ones, and the codes on the right always have an even number of ones. So if the computer reads an even number of ones on the left-hand side, it knows that the barcode is flipped upside down, and once it reads it, it can just flip the numbers around before processing them. Also, as an additional error check, all the codes on the left side begin with a 0 and end with a 1. And all the codes on the right side begin with a 1 and end with a 0. So in this case, we'll plug in the numbers above, and you'll see that those numbers are the exact same as the numbers below. But what do these numbers actually mean? Well, the first number on the left-hand side, the 0, which is outside of the actual barcode, tells us what type of barcode this is. A 0 is a standard barcode, a 2 is a weight item like fruit or meat, a 3 is a pharmacy item, and a 5 is a coupon. The next set of 5 numbers tells us who the manufacturer of the product is. In this case, it's the Campbell Soup Company. The second set of 5 digits tells us the product code, which in this case is a 10 3/4 ounce can of chicken noodle soup. And finally, the last number on the right-hand side is called the modulo check character, and this is another form of error checking. When the computer scans the barcode and processes the numbers, it needs a final way to know that it read and processed everything correctly. So it performs a calculation and comes up with the modulo check character. The modulo check character formula is actually based upon the positions of each of the numbers at the bottom of the barcode. It first adds up the digits in the odd numbered positions, and then it adds up the digits in the even numbered positions. It then multiplies the odd numbered digits by 3 and adds that amount to the sum of the even numbered digits. So we'll go ahead and plug in the numbers from our barcode, and we come up with a final total of 23. We then subtract the result of this formula from the next highest multiple of 10 to get the modulo check character. So the next highest multiple of 10 after 23 is 30, and 30 minus 23 is 7. So we know that we have read the barcode correctly. So now you've learned barcodes in one lesson.